Hey everyone, a very warm welcome back to the channel. Now, today we will be taking a look at two more different solutions of the questions that we have already seen. The question number 5. The question says find the number of roots of the equation e power x is equal to 1 plus x power 1 upon 1 factorial all the way up to x power 100 upon 100 factorial. Time allotted we can say is 6 minutes, and ideally you should try to do it within 2 minutes. Answer we already know is 1. One root will be there, which is x equals to 0. Concepts and formulas used can be Rolle's theorem, which we have already seen earlier, this method. And then there is also a method using Taylor's theorem, which is written here, right? So Taylor's theorem also, if we know, then the question can be easily solved. So this method number 1, we have already discussed earlier. Now let's see method number 2. So if we apply Taylor's theorem on the function f of x, where f of x is simply e power x and a we are choosing to be 0, then by Taylor's theorem there exists a c belonging to real numbers such that e power x minus tnx. What is tnx? Taylor polynomial of nth degree for the function f of x is equal to e power x is equal to the remainder function rnx for all x, where tnx is simply going to be this expression, because we know this is the Taylor polynomial of nth degree for e power x, and rnx by definition comes out to be this much, because no matter how many derivatives you take of e power x, look, Rnx, when we are talking about, we need to take n plus 1 times derivatives, right, of the function. So no matter how many times you take the derivative, it will still be e power x only. So that's why e power c, this thing I have written. So since we wish to actually solve e power x is equal to t power tnx, so this is the equation that we wish to solve for n equal to 100, right? So that would imply that this thing becomes 0. So Rnx must become 0. So this quantity must become 0, but clearly e power c can never be 0. It is always positive. N plus 1 factorial is positive. So x power n plus 1 must be 0, and hence x equal to 0 is the only root. Now another method is there, method number 3. Method 3 basically relies on the fact that we can multiply both the sides by e power minus x to write the equation in this form. Now f of x can be taken as this function minus 1, very obvious. Now, derivative when you find f prime x, that simply comes out to be just this small term. Why? Because we should know whenever we are differentiating e power minus x into g, its derivative is equal to e power minus x into g prime minus g. So when you will find its derivative and then subtract this function from that, you will only be left with minus x power n upon n factorial. So that's why this is f prime x. Now, when we consider x greater than 0, it is very obvious that this is going to be less than 0, because these things are anyway always positive. Now the sign scheme only depends on minus sign and x power n, right? So for x power x greater than 0, x power n also greater than 0, but this negative sign will make it negative. So f prime x will be less than 0. So fx is decreasing for all x greater than 0. So fx must be less than f0 in this interval, and f0, obviously you can see f0 will come out to be 0 only. Just put x equal to 0 here. Easily we can see f0 is 0. So fx is always less than 0 whenever x is greater than 0. Now for x less than 0, we can take two cases. First case, when n is odd. In that case, f prime x will be greater than 0. The reason is, since x is less than 0 and n is odd, x power n will also be negative, because negative power odd number is negative, but negative into negative will be positive. So f of x is increasing in this case for x less than 0. So fx would be less than f0, but f0 is 0. So fx is less than 0 for all x less than 0. Second case we take when n is even. In that case, we can easily observe that f prime x would be less than 0, because if n is even, then x power n will be positive only. Anything to the power even is positive, but due to negative sign outside, it will become negative only. So f of x is decreasing, and thus we can say f of x must be greater than f0 in this interval, which is 0 only. So fx is greater than 0. So we can observe that for any x which is not equal to 0, fx can never be equal to 0. Either it is less than 0 or greater than 0, but never equal to 0. So x equal to 0 is the only solution of this particular equation. So these two solutions are also very amazing and very short solutions. So I hope this will help you out in solving these kinds of questions. I hope you like the video. Make sure you comment down below what more you would like to see next. Subscribe to the channel, share it with your friends, and hit the bell icon to never miss an update. And I'll see you all in the next one.